Scalar product. You need to know the scalar product and how to use it in both 2 and 3 dimensions. The first step is to understand what is meant by the angle between two vectors. If both vectors point outwards, so here we have a point with both of the vectors going outwards from that point. So this is the angle theta in that case between the vectors A and B. If both vectors point inwards, so here's a point and both vectors are coming in there, then this is the angle between A and B. But if one points in and one points out, like this, then the angle between A and B is actually found by extending one of the vectors on and doing the angle between that vector and the extension of the other vector. It doesn't matter which way round we do that. If you think of this angle here, then this is just simply 180 take away that angle. The scalar product of two vectors A and B, as shown below, we're going to show those in a moment. So here we are, they're the vectors A and B with an angle between them of theta. That scalar product is defined to be A dot B. Sometimes people call this the dot product because the scalar product operator is a dot. So when you see A dot B, that is the scalar product or dot product of the vectors A and B. And that's equal to the modulus of A, which is the length of the vector A, times the modulus of B times cosine of theta. Well, of course, that's not a vector, it's a scalar, and that's why this is called the scalar product. We're taking the product of two vectors in such a way that we get just a number. This has several implications, such as since the cosine of 0 degrees is 1 and the cosine of 90 degrees is 0, if A and B are parallel, so in the same direction, that means that cos theta is 1. And so A dot B is just mod A mod B. And if A and B are perpendicular, that means at right angles, so the cosine is 0, then A dot B is 0. And this one is really important. The last point is important because as a consequence, I dot I is 1, J dot J is 1, and K dot K is 1. Remember, these are unit vectors, so they all have a modulus of 1, and obviously I is in the same direction as I, so the cosine of 0 is 1. But, and this is where it becomes interesting, but, and this is the key point, I dot J is equal to J dot I is equal to I dot K is equal to K dot I is equal to J dot K is equal to K dot J is equal to 0, and that's because the vectors I, J, and K are mutually perpendicular. So therefore, the cosine of 90 being 0 gives us that I dot J, for example, is 0 because it's 1 times 1 times 0. Because of this, if we just take the dot of two vectors, consider what happens with A1. We really need to dot A1 with B1, then with B2, and then with B3. But only A1 dot B1 gives you anything because this is the I components. I dot I is 1, but when we do the I dotted with a J or the I dotted with a K, it gives us 0. So it's just going to give us A1, B1. And then the same thing with the A2 here. It's only going to give you a value with the B2. So A1, B1 plus A2, B2 and then plus A3, B3. And we'll look at that in some examples. We can rearrange the definition to find the angle between two known vectors. Cos theta is A dot B divided by mod A mod B.